What's up guys? Welcome back to Vanover Machine and Repair. And in today's video, we're going to be turning these two beautiful logs of steel into 5 pins for a customer. Let me bring in close and show you the details. In regards to the material for this job, we have this nice 4 1/4 inch piece of 1045. We're going to be cutting in half and making 2 pins roughly 24 inches long. Pretty straightforward on this one. On the other one, we have a nice 3 1/4 piece of 4140 annealed. We're going to be cutting this down and making 3 pins from this. These pins are going to be a little bit more unique because they have recessed grease grooves, and we're going to be cutting a spiral, and it's just going to be a little bit more interesting than your basic pin. I've been doing a ton of pins in the last several months and really haven't shown you much of that just because it's rather repetitive, but I think this job will have a nice variety and I thought I'd bring you along for the journey. Now I do want to talk a little bit more about the precision of these pins and the application, but other than that, we're ready to get these guys cut up and start machining. So I think it's important to talk about the context of this job. I know a lot of you guys appreciate the backstory and why and how. And to be honest, this customer loves stuff QCC, which means quick, cheap, and close. They don't want things perfect, they don't want things expensive, and they don't want things slow. I love to do a quality machining job, and the other machinists out there know how that is. But frankly, these jobs go like this. I get a call, I drive out. This company is super busy. They probably have 30 employees, and they probably have maybe 100 to 300 pieces of equipment in their yard, ranging from small to the size of 3 or 4 buses. And they basically rent out machines and sell machines and attachments. So I'll get out there, I'll take a tape measure and some calipers with the guy, we'll measure it, we'll sort of guess on the dimensions based on nominal sizes, and then I'll dial it back like about 1/2 millimeter on the diameter, and as long as I'm within like 1/4 inch on the length, that's good enough. And I think that's important to understand because I love doing a super fine quality job, but that's just not what these jobs are. As much as it would be better to make sure that these large pins are a nice slip fit on the bushings, there's a time and place for that, but that's not what this is. So with that being said, let's get this material cut up. Now I know you guys have been really liking the commentary recently, so I'll throw a little bit in while we're getting this piece of material cut. The material we're cutting, we're using the Hyde Mech S20. I absolutely love this saw. It's one of the only pieces of equipment in my shop that I purchased, brought it in and did nothing to. It's 30 years old, it cuts straight, it works every time. Amazing piece of equipment. They do make a smaller 12 inch, I believe, maybe a 15. I would highly recommend the bigger unit. It allows you to have a larger cut capacity. It seems like every machining job I do starts with this saw or ends with this saw. It is a tank. As far as the blade, we're running a 6 TPI German blade. They're about $105 each, and they last for forever. Usually I break them before they wear out, probably by cutting something I shouldn't or by letting the head feed too fast. Being 6 TPI, they're a little more sensitive to the feed rate, so if you're cutting some tube or something, they can catch if they're not feeding at the correct rate, so you got to be careful with them. Our pin is 11 1/4 long, so usually I add 2 inches, and then we come in here and center drill so we can give us some support. It's ideal if we can go ahead and face this first, especially on longer pins though. It gets a little bit sketchy because you just don't have the support. But if your cut is really off, your center really isn't going to like that when it spins around. You can also use a puck. A puck's nice if you don't want to add a center in the end. There are times when you can't do that or the center is damaged, and you can just use this to kind of put pressure that way, but they each have their application. We're going to try to face this off, see if we have enough rigidity to do so, and if we do, we're golden. If not, we'll go ahead and just center drill it. I like to use a DNMG here. The CNMG is slightly more durable, but the DNMG has less tool pressure. so the part is less likely to bounce around because you're putting less force on it. This piece is pretty straight and it's gonna play nice, so we'll be able to face it off no problem. The bigger the diameter, the easier it is to run with a lot of stick out when facing. This worked out well. Now let's throw a center in the end. For the center drill, I'm using a carbide number 6. I just recently started using these carbide centers. They're pretty nice. They can be kind of pricey. I just get the cheapest ones I can. They work really nice, especially on harder material where the high-speed steel can kind of burn up, but I pretty much always break them before they wear out. Also, less tool pressure as well since they're sharper. So in these areas where the material is unsupported, it's less likely to wander. It stays rigid and makes everything a little bit more precise. If the high-speed steel ones are dull, they can kind of flex and walk because they're not cutting, so that's where these come in really handy. I'm going to turn down a step so I can flip this around. I like to do it. It just allows me to make some heavier passes without the part migrating, like it is right now. It's an extra step, but I really enjoy doing it. Once I put the work in up front, I can just take whatever size pass I want. I don't got to worry about the work moving on me. A couple taps with a hammer helps me get it straight, and I can wrench it down. All right, as far as inserts, we'll do a separate video on these that needs to be a lot more detail oriented, but I always get questions, what do I use? So really, I mostly use these 2 ISCAR packs here in the CNMG style. One, I have it labeled less durable, that is the 907 grade. These are better for harder materials, and I have it in a 431, so I take a less shallow cut, which is common on harder materials. And they're better for that, but they chip easier. The 928's more durable. I have it in a larger radius. It's better for interrupted cut, and that's what I use a lot of times for roughing. Now, the reason I use these guys is because they're cheap. I don't know what they originally retail for, but probably $10 an insert. I get these on eBay for like $10 a pack. I don't know if they're counterfeit or what, but that's dirt cheap. So these are better than the Chinese no-name brand, but they're pretty much the same cost. That's why I use these. The best style of insert is this style here, which is the gold and black. And I'm not gonna get too deep into the grades. Those of you will point out what grade this is, but you can just tell by looking at this insert, it's much nicer. I have a Coralloy one here that my rep gave me to try out. It's a grade 3235. This is my favorite style of insert. There's a Kyocera one, and Kennametal has their own. They're all very similar, but it's just this look. It's a similar type of coating and like structure in the chip breaker. So don't get too caught up in the name brands. More so it's the style that I'd be more concerned with. These are better, but I haven't found these cheap. So when I want to do a really nice job, I'll use something like this. But for most jobs, I just use these cheap ISCAR ones. They work good enough and they're way cheaper. This really wants a deeper cut. Notice all the rings here. So we're gonna back it off. That's like 1/2 mil, 30 thousandths maybe. There we go, that's gonna be happier. Notice the finish is better. It's like 2 mil maybe 100 thousandths. We're running at 1,000 RPMs. I have no idea what the feed rate is. Kind of doesn't matter, I go by feel anyway. I'm gonna take 3.5 millimeters. Probably get a better surface finish, yep. Always want to clean that pad out. Here's a brand new insert. Everything's the same. We split our last cut in half. Depth of cut's the same, feed rate's the same, RPM's the same. The only difference is the insert. See how it does. There you go, that's what your money's paying for. With that other insert, that's pretty much the best finish you can get. With this insert, it just comes in and gives you an even better cutting action. It's dang near perfect. Not quite, but almost there. Notice how much nicer that surface finish is, and that's the same, everything except for the insert. So I think we could get a little bit better finish with that insert by optimizing the feeds and speeds, but this is definitely beyond what's necessary. The last one was probably beyond what's necessary for a bucket excavator attachment. The insert does make a difference. You know, you do get what you pay for, but maybe you don't really need this. So this is pretty much as good as it gets. It's probably 95%. I think I could get another 5–7% better. But yeah, you know, no one's gonna be upset with that finish, I can tell you that. Now that the OD is turned down, we're gonna work on the more interesting feature of this part, and I welcome your criticism to see what the best way to do this is. So we're gonna be adding a spiral to the center section of this pin. This pin, when installed, is captured on both sides and pinned with a 7/8" bolt, and then another piece of equipment comes on here and rotates in this area. The customer wants me to drill a hole in from either end and then drill a cross hole down to meet that hole and then machine a spiral so that way when this part is on here and you pump it full of grease, the grease will come up through this hole and kind of go around to fill up that spiral and thus lubricate this section. Now I think if this was a really nice tight fit, that idea would work perfectly, but I know that we're making this probably about 1 millimeter undersize, so I don't know that the spiral is actually gonna work as well as I thought, but that's what the customer wants. The other idea that I had would be to drill a couple holes around here, and since we have so much clearance, the grease would basically come up and kind of surround the pin, but I'm curious to know what you guys think in terms of what's the best way to grease the pin in an orientation like this. I know most situations involve greasing the actual bushings, so that's fine, I know how that works, but specifically greasing the pin from the pin, I'm curious to know what you guys think. So with that being said, we're gonna address some of the change gears in the back of this lathe so we can set up and cut this spiral. Get our tooling cart removed, open up this cover. All right, you guys get to see a nice little secret. I'm gonna show you the back of my lathe and you're gonna see something in here that you would not have guessed. I had to do a metric job a while back and this machine isn't set up for metric. So I made some custom transposing gears and I made them out of plastic. And they've been in here for close to 6 months with no issues. So this gear is plastic, plastic, plastic. And I've been running these 3 gears in lieu of the original metal gears for the last 6 months, and these gears are holding up great with all types of heavy cutting. So a lot of you guys have been asking me about the speeds and feeds, and I told you I don't know. Well, I literally don't know, because when I put these other gears on here, my feeds chart doesn't mean anything anymore. So we'll go into this in more depth in another video, specifically on using 3D printed gears in a lathe to achieve metric threading. But in this case, we're removing these now because I need to be able to use my threading dial to find the same spot. And when you have it set up in metric, your threading dial doesn't repeat in the same spot over and over again. You have to leave the half nuts engaged. We'll switch these back to the standard gears. That way we can use our threading dial and we can come back to the same spot. Let me get these swapped out and move over to our old gears. Just a snap ring that holds these on. All right, we got our change gears back installed and everything is good to go and back to stock form. All right, we're ready to cut the spirals. So 4 1/8 from the end. and we're gonna go down to 8 5/8. This is not precise. I'm gonna start the lathe and see if I can pick up my line. All right, so our spiral will go in that center section. And what I'm going to do is I'm gonna come back here and engage, and then once I'm engaged, I'll feed in. That way, if I miss the engagement because the dial is moving quick, I don't have to worry about jumping the thread. So we're gonna come down on 1 and then go for it. Help if I feed in, right? Look at that, I'm human. Look at that, we went and touched where we shouldn't have. No big deal. It's an excavator pin. No one cares. We got this shaft finished out, and as you can see, we left this happy accident in there. I didn't edit it out. I make mistakes. It's hard to do things perfectly, especially when you're filming and you're cutting an aggressive thread. It's easy to have too many things going on and slip up like that. Luckily, we are 0.3 mil oversize. I measured this out and we're at 75.2. Again, I was less concerned about the dimension and more showing you the surface finish earlier, but in this case I think it's going to work to our advantage because we have a little bit more material to remove, and maybe we can move this mark here. So we're using a DNMG tool holder. It's got a much sharper point, and we're using a 431 radius. So even though we're only taking 0.3 of a mil, we might be able to get a somewhat decent finish, although it still will be worse than this. So let's get this cleaned up and then we'll move on from there. I don't know. Oh, we got it. We got it cleaned up. Honestly, surface finish isn't too bad. Could be worse. DNMG never disappoints me. Never. 22 thousandths per rev in case anyone's curious. 1,000 RPM. All right, let's clean up this face. I'll do as much cleaning up with the center on there as I can. Then I'll pull my center away. Finish up that last little bit. There we go. Chamfer. That's it, nice heavy. All right, we're gonna part this off at 11 1/4 inches. Double check with my tape. Looks good. Yeah, that might have been a little aggressive on the feed. There we go, much better. I do want to chamfer that. Just making some room. Oh yeah, great. We'll come in here and give our 45. There we go. And we're back to chamfering. And we're back to parting. I am using the power feed. My parting blade is a little bent. I should replace it, but it is what it is. Now we have tailstock support, so I'm gonna get it close and then remove the support. I like to leave about a 1/4 inch remaining, and then we can remove the tailstock and break it off. There. All right, now we're gonna clean up the end that we just parted off. All right, we'll put a center drill in the end. All right, now that we got this pin done, except for the grease holes, I'm gonna get it out and I'm gonna do the other 3 up to this stage. I'm not gonna give you any commentary on that. We'll just give you a couple shots and speed right through it. And then we'll drill all the grease holes at one time in an assembly line. $15 thou per rev, up from 8 on the last pass. All right, there's the second one done. I'm gonna do the third one off camera. No need to show that. And then we'll meet you back to drill the holes for the grease fittings. There we go. Well, now that our 3 pins are done, we can come and drill the grease holes on all 3. We're gonna be countersinking first. That'll allow our Zerk fitting to be below the surface. I'm using this spade drill. You really want to run these with coolant, but I found that if you use the carbide and we're not drilling deep, it works perfectly. Really, the heat is the issue, and on the high-speed steel bits, they heat up and they dull pretty quick, but the carbide is a little bit more durable, so I found some success running these dry, as long as we're not doing any deep boring. So let me do that counter bore first. 725 RPM. I'm going 3/4 deep. There she is. Put a nice heavy chamfer on this. Now we're gonna start drilling our hole. We're gonna be using this anchor lube. Works really well, stays on the drill bit. We're using a 5/16 drill bit, running 725 RPMs. We're gonna be doing an 1/8 27 Zerk fitting, and that is a letter Q drill, but the 5/16 is a little bit easier to come by in a long drill. So we're gonna start with the short drill, then we're gonna move over to the long drill, then we're gonna finish out with a Q drill, and then we'll tap it, and we'll be done. A lot of switches on doing these grease fittings. I did use oil in the past, but this stuff's nice because it stays stuck to the bit. Doesn't work well for everything. And the one thing I don't like about it is if you don't clean it up, it kind of hardens on the machine. So I really don't like that. But in applications where you want stuff to stick, like tapping or even using a hole saw, like, works pretty well. Just like everything, it has a use, but you know, it's not gonna be a complete replacement for oil. And when I'm drilling, I'm basically coming in, I don't know, maybe 1/4 of an inch, backing out, clearing my chips. Deep drilling is all about patience. It's not hard, but it's patience. If you're impatient, you're gonna make your life difficult. Just like that, we got our Zerk fitting here, we'll screw in. All right, this side's done. Let's flip this guy around. Work on our next side. Oh, that's not any fun. Look at that. First carbide center broken. Probably because my drill's dancing around in the hole. That'll be fun to fix. Lots of mistakes in this video, guys, but hey, you know what? That's how it goes. So we have a carbide center we broke off in there. Why did that happen? The inside of this quill is pretty dinged up. It has been for a while. Carbide drills are more sensitive to misalignment. I need to go ahead and buy myself an MT4 reamer and just clean this quill up so that my drill seats a little bit more securely and doesn't shake around. I kind of felt it, but then it was too late. Anyway, how are we gonna get this out of here? So with carbide, obviously you're not gonna be able to drill that out unless you got a diamond drill bit. The best thing that I found is just to try to break it. So it's just the tip. So we have a nice snap-on punch. I'm gonna see if I can get in here and just kind of smash it and break it into pieces. And then we'll come in there with the next size up, carbide center, and clean that up. Yep, just it's literally breaking apart. That's the good thing about carbide is it's brittle. We need to get all the pieces out of there. I'd honestly kind of rather break a carbide than a tap that's high speed, because at least with this stuff it shatters. All right, I think I got most of that out. We're gonna use this carbide center. Key here is just to go slow. I know you guys can't see in there. Hopefully the chips will kind of catch and fall out. I think we're good. I'm gonna switch to a bigger one, high speed, and just clean it up, and then we'll get back to drilling. All right, we're over here at the milling machine. We're ready to drill our cross holes. The accuracy and centering is not that critical, so we're gonna use a little trick that I like to use. Bring this down and basically go until it's level by eye. Looks good to me. So that'll be on center within reason. We'll come over to our first hole here, and we're using one size under 1/4 inch, no reason, and we're gonna drill down until we hit our hole. I'll slow my speed down. There we go. There's one. There's two. All right, we got our holes drilled, everything's finished. Last step, just put in the grease zerks. Made sure to blow out all the holes. Make sure everything was nice and clean. All right. We got our 3 pins done and they turned out pretty good. Aside from breaking some taps and center drills, they went relatively smooth. We're gonna move on to the last 2 pins, which is gonna be made out of this 48-inch long piece of 1045. We're gonna be cutting it in half and making 2 24-inch-ish long pins, 100 millimeters in diameter, and they're gonna be necked down to 90 millimeters in the middle. So we're gonna get it over to the saw and get this guy cut up. This skyhook is cool, no doubt, but there's no replacement for a jib crane. But I don't have one over here yet, so this will have to work for now. I also need a jib crane over at my boring mill, so I'm kind of trying to prioritize. With this much stick out, you really don't want to do any machining. But I found from experience, if we can get it running true and I can reef on the chuck at that end, if I'm gentle, I can come in here and put a center drill in the end. I'm showing it to you because that's what I'm doing. Do that at your own risk. The center drill doesn't really put a lot of torque on the part as long as you go slow. Otherwise, the proper procedure here would be to put the puck back on, put the center in, cut a steady band, or grip this with a revolving 4-jaw chuck, cut a steady band, get a steady rest, all that just to get a center in. We're gonna show you this works this way, but you know, do it at your own risk. Using a carbide center, a large one, a number 7. We're just gonna take it slow. The larger the center, the better here. And then quickly withdraw it. There we go, our center's in there. We didn't need a steady, we're good to go. We'll put the center back. Now this face isn't running perfectly true, but it'll be enough to work and it will save us a lot of setup time. Again, do that at your own risk. We got a 20,000 speed rate, touch off. Here we're tight on our center. There's not much time to waste, so we're gonna be efficient with this. 107 millimeters. Here we go. We have a little bit of chatter in the beginning. That's because our center isn't running true and we're taking too heavy of a cut. If we take a lighter cut, it would go away. But we're working quick on this. We gotta turn these out. Okay, never had this happen before, but we're not spinning on our feed shaft. I checked over here, it's not that. We're engaged. You would think it'd be maybe a roll pin, but that roll pin looks good. So we're gonna have to take a look in the back of the machine, see what's going on here. It's twice we had to get into the back of this machine for this job. All right, let's take a look. I'm guessing some sort of a roll pin, or at least I'm hoping it's a roll pin. Okay, I don't see anything wrong. So this will be interesting. All right, we're not getting any spinning. All right, I gotta do some investigation. I'll come back once we know something. I've had a roll pin break before on the shaft here, but it seems like something's disconnected in the head. The gears spin freely from there all the way over, so we're gonna have to get into the head, Hopefully it's not too bad. This job needs to be out of here in 3 hours, maybe 4. Let's see what kind of magic we can do. It's definitely nice in this situation. Someone forgot to press record. Anyway, we got the head off. All right, here's a little bit of an update. I know you can't see in here, but let me explain what's going on. So down inside of here, there are 2 dogs, and it looks to be a shifter. And what I believe engages the feeds, that dog is in the middle, and it's not over. Now, to my knowledge, I know this machine pretty well, there's not a knob that engages that dog. So I'm going to pull this cover and look at it. Either I'm having a massive brain fart, or something's going on, or something disengaged that, and it's basically just like an engagement. So I don't think anything is broken per se. It's kind of like it kicked out of gear somehow. All right, guys, I'm done. Turns out the reversing and forward disengages the feed, and somehow, some way, I bumped that lever over there, and I almost never use it, only if I'm doing a really interesting thread. But it was right in between, and that controls that shift lever. So a whole lot of hubbub about nothing. So I'm going to clean this up off camera. I'll meet you back over at the machine, and we'll finish this cut. But hey, you know what? A lot of learning in this job. All right, we're back. Let's get back to work. $20 thousandths per rev. We're trying to get this job done in the next couple hours, so we're really trying to move without being unsafe. Yes, I did end up wasting about 2 hours because I was unaware that I pulled a lever. That does happen in my shop from time to time. Taking 2.5 millimeters off the diameter. We're at 102.7-ish. We need to come down to 100. So I noticed we were getting a lot of spring back around here. It's because I'm cutting heavy and the center is moving. So instead of taking the last 2.5, I'm taking 1.5 right now, and then I'm going to finish with 1 millimeter. That'll give us less deflection at this end and a little bit more consistent size. Surface finish is better as well. We're getting like a 1-inch long chip. Not ideal, but it is what it is. They're kind of jumping everywhere. All right, we have less spring back down here on this side, doing it with a lighter cut. I'm measuring these out with a mic at 100.95 millimeters and 100.85 millimeters on the close end of the chuck. So we're getting 0.1 millimeter of deflection, which is a lot better. Before we were getting about 0.3. The last amount we have to take off is a little bit less than 1 millimeter. We're going to get some deflection down here. I'm accepting that. But with the tolerance of this pin and it being a little bit undersized, it'll be completely fine. So let's come in here and take that last 0.8 or 0.9 millimeter. And I'm shooting for something that's a little bit undersized of 100. So usually I do like 99.90 or 99.95. These guys never like the stuff right on size. They want it a little loose. All right, now this is for a quick attach coupler. So the one attachment is 100 millimeters, but the claw is 90. So this is a type of thing I do all the time, where they want, where it comes into the boss, the nominal size, and then the center section is to attach a different attachment, which is in this case 90 millimeters. So I've been given the dimensions of 4.5 in from the end, and then 17 long, and that's going to give us our relief section in the center. Usually I'll chamfer on each side. It doesn't really matter, and even if it was 85, it wouldn't matter. There's a really, really, really loose tolerance on it. So we'll touch off the end, come in 4.5 and then down 17 and then make a mark there, and then we'll relieve that section at 90 millimeter. Then I'll work down to the shoulder, and then I have a DNMG in the other position. I can work back to this shoulder when I'm done. There we go. It's a nice healthy cut. I think that's 3 millimeters off the diameter, 1.5 millimeters in feed. That insert isn't bad. A chip is caught there, I'm pretty sure. There it is. You can tell this insert doesn't like these deeper cuts because it's a 431. It'll do it though. All right, I got this roughed out. It's within 0.5 millimeter. So now we're gonna switch to my DNMG going the other direction, clean up this shoulder down here, and then we'll make our finish pass with the DNMG. And I didn't want to run it right up to that edge. I want to come in here like this, kind of face it. All right, we got a new insert in there, and we have about 0.8 millimeter to remove. So what I do is I come in here as close to the shoulder as I can, make a long rip, and then I'll clean up this little section with this other one. All right, something happened there. Oh, man, this video is full of mistakes, guys. I had the feet set the wrong direction. Wow, that is ridiculous. Man, you guys are seeing the worst version of me today. Wow. All right, well, that probably made for a cool chip. So it chamfered that, basically, which is fine. I needed to chamfer it anyway. Wow, this is a rough video. I'm just gonna be honest. Well, I guess I don't have to clean up this area anymore, huh? Man, you know what? I'm gonna leave this video as it is. I'm not gonna edit this crap out. If people wanna whine about how I'm not a good machinist, they can do that. I don't care. I made a lot of mistakes today and yesterday. But hey, you know what? We're gonna get this done. It's gonna work out fine. We made our mistake down there. Now we gotta match it. I do usually chamfer this, but I don't chamfer it as aggressively. But we are now. Looks nice. Next step is to chamfer the end. All right, we got this pin finished out pretty much. I'm gonna take it over to the saw. We'll trim this, flip it around, chamfer face, center drill, call it done. And then all that's left to do is the cross holes on all the pins. All right, let's put a center in the end of this thing. Nice and gentle. See, I got a nice brass stopper there. I'm using that to kind of help, kind of as a steady. Again, this is not really recommended here. I've just found that this works. Let's get this face. 24¼ is what I'm looking for. Looks like we got a 1/16 to take off. That's it, nice and quick. All right, that's pretty close. All right, here we go. So far, so good. Nice and easy. Let me take off less. There she is. We got it faced. Maybe a little hairy, but we got it done. All right, this part is done, minus the holes. We got all of our pins done. The last step is to come in here and drill our cross holes. So on these three, it's gonna be 7/8 inch hole, 7/8 inch from the end, and then these ones are gonna be a 1-inch hole, 7/8 from the end. So let's get these over to the Bridgeport and get these holes drilled. Just when I thought I was rounding the corner, I noticed we have a huge mistake or error. I was going off what the customer wanted. I was moving quickly, reasonably, and there's a conflict here. We need to put a cross hole here, and we have our grease fitting, and we did all that work so we could be able to grease it from both sides, because that's what the customer wanted. That's not gonna work, because this bolt is gonna be blocking this grease hole. So what we're going to do is we're going to try to make it right, and we're going to drill that hole. We're going to pull out this Zerk. We'll take it over to the machine. We'll countersink this, drill it, tap it. I'm not going to show this. And then we'll take our long drill bit and we'll basically drill it all the way through so that from this end you're able to get grease to this hole. Because right now there's a land in here in the middle so that it could be greased from either end. So with this hole plugged, aside from having an extra hole in the end here for that counter bore, everything should be fine. It's going to be extra work, but let's try to make it right. I didn't see around this. I should have, but hey, hindsight's 20/20, right? All right, we're going to go ahead and drill these on the radial drill just for efficiency. I've already found the center and everything, so let's get to it. Flood coolant would be better, but I don't have it on this machine. It'll do it. There we go, my feed wasn't on. Running 252 RPMs, and I did step it down to 6 thousandths per rev. Well guys, these pins are done and I'm on my way out the door. They turned out pretty good. At the end of the day, this last mistake we made on this 3 actually turned out to be fine. We drilled all the way through and I flipped them around and tapped the back side and put a set screw in there. And if I would have drilled through each side, I would have had a hole that I needed to cap off anyway, so that ended up being fine. So now we can grease the pin to both holes from one side, so that should be real nice. Everything else ended up turning out very good. A lot of suffering, a lot of struggling in this video, but you know what? That's how it goes sometime. So I know the customer's gonna be happy, and let me know what you think down below. I'm curious to know about these grease grooves and drilling from both sides. I wanna hear your feedback. I don't do that all the time, and I'm wanting to get better if there's better techniques. So let me know down below, and until next time, we'll see you in the next one.